All right, so for this section, we are looking at what we're calling differential equations. And that just simply means we have an equation with our derivatives in it, okay? So we want to see if we can verify that the function y, we want to see if it's actually a solution of our differential equation, okay? So basically what we're going to do is we're going to first find the second derivative of our function. Then we're going to substitute in to our differential function to see what we get, okay? All right, so first, let's go ahead and substitute, okay? We're going to substitute in our y into our derivative function. So we're just simply going to rewrite it, y double prime of t plus 121. Now, in the place of yt, we're going to simply write all of this, okay? So we got 121 times c sub 1. C sub 1 is just some constant, okay? So just simply rewriting all of this into the place of our equation, okay? So now what we will do from here is simply distribute our 121 through. So we get y double prime of t plus 121 c1 sine of 11t plus 121 c2 of cosine 11t. Okay? All right, so now that we have that, the next step that we want to do now is actually find our second derivative function, okay? So how will we do that? Well, when we look at our y of t function, we need to first find the first derivative of that, okay? So let's see if we can remember how to find the derivative of function. So we have this sine of 11t, right? When we have that c1 in front, that's just a constant. We will just pull that down. But remember, to find the derivative of this, you have to take the derivative of the inside times the derivative of the outside, okay? So we're going to simply bring down the constant c1, and then now the derivative of the inside here, well, that's just 11, and now the derivative of the outside, so the derivative of sine is just cosine, okay, keeping the inside the same. All right, now bring down the other constant, c2, and now do the same here. Find the derivative of the inside times the derivative of the outside. So the derivative of 11t is just t. And then now we know the derivative of cosine is negative sine, okay, keeping the inside the same. All right, so if we distribute all of this and kind of rewrite it a little bit, I'm going to bring my 11 in front here, bring my minus and my 11 in front here. So we'll get 11 c sub 1 of cosine 11t minus 11c2 of sine 11t. Okay, so that is our first derivative. But remember, we're trying to find the second derivative. Okay, so that means we got to find the derivative of the derivative. Okay, all right, so pretty much the same idea. Here, these are just constants, and so then when we take the derivative of our cosine 11t, remember, kind of like the chain rule, right? Take the derivative of the inside times the derivative of the outside. So when we do that, bring down our 11, c1 times the derivative of the inside is 11, the derivative of cosine is sine. All right, and do the same thing over here, bring down those constants. Okay, the derivative of the inside here times the derivative of the outside, so 11 cosine 11t. All right, so let's put it together. Okay, so we're going to go ahead and distribute all of this, and then here we multiply the 11s together. So we end up getting negative 121 c1 sine of 11t minus 121 c2 cosine of 11t. All right, well, let's take a look at what we have, okay? So we want to kind of compare and see if we get something similar, okay? Well, take a look at what we have here and compare it to what we have here. Well, this is equal to 0, right? So if I take this and I set it equal to 0, right, do I get the same thing? Well, here I have the y double prime t is on this side, and when we look up here, we see that all of this is on the same side as the y double prime of t. So, yep, if we bring all of that over, the signs are going to change, okay? So, therefore, we get the same thing, right? So, we get y double prime of t plus 121 C1 sine 11t plus 121 C2 cosine 11t equals 0. Okay, so this matches exactly that. So what does that mean? We wanted to verify that y is actually a solution. So we can say yes. All right, the given function is a solution of this differential equation. Okay, so I'm kind of abbreviating here my differential equation. Okay, so since we got them to be the same, right, we can say, yes, this is indeed a solution. Okay, so therefore we can say this statement, right, or this equation, we can say the result is indeed a true statement. All right, and we're done. All right, so for this one, here it says to simply find the general solution for this differential equation. So basically, all that's saying is for this differential equation, again, we know it's a differential because we have the derivative there. We basically just want to find, well, what is the y of t? Okay, so what is the function that would satisfy this derivative? Okay, well, we know that in order to find y, we would have to find the derivative of the, we have to find the integral of the derivative, okay? So we just simply find the integral of this 4 plus e to the negative 7t, okay? All right, so we know the integral of 4, well, that's just 4t. And then we know the derivative of our e is just simply e to the negative 7t divided by that constant. Okay, and then since we don't have any bounds, we have an indefinite integral. So therefore, our general solution is just simply 4t minus e to the negative 7t over 7 plus c. Okay, so we call that a general solution, right, because we have that c there. So anything, any constant here would satisfy this differential equation. All right, well, what if we have this as our differential equation and we want to find the general solution that's going to satisfy this, okay? Well, again, we know in order to find our y of t, we got to find the derivative of our, the integral of our derivative. So we find the integral of 2t ln of t plus 4, okay? All right, so if you want, you can split this up into two integrals. We have the 2t ln of t dt, and then plus the integral of 4, okay? All right, well, let's look at the first part here, okay? You can see we have a 2t and we have an ln t, okay? So we have two functions being multiplied together, so you can think of, all right, we got to do integration by parts, okay? So let your u be the ln of t, because we know we don't really have a rule for the integration of that, so therefore your v of t, that's going to be your 2t dt, and then your du then, well, that's just 1 over t dt, and then of course your v, well, the integral of that, that's just simply t squared, okay? All right, so put it all together, then we are saying our y of t is equal to, okay, your u and your v together, so 2t squared ln of t minus the integral of your v du. All right, and then don't forget about this other integral up here that we haven't touched at. We're going to go ahead and bring that down. Integral of 4 dt. All right, so what do we get here? Nothing happens with this part, just bring it down, but then this piece simplifies to just t, and then we got the integral of 4. All right, so t squared, ln of t, integral of t is t squared over 2, and then the integral of 4 is 4t. Then again, it's an indefinite integral, so plus c. All right, so final answer if you want, you can rewrite it as t squared ln of t minus 1/2 t squared plus 4t plus c. And there you go. So we would say that this is our general solution that's going to satisfy that differential equation.